So can you see the notes properly now? Or can I zoom it? So this is what we started in the last class. The solid state. If you are preparing for the board exam, CBSE board exam, totally you will get the 4 marks, and 1 mark is a very short answer, and the 3 marks is a short answer. Okay, but we don't know, right, whether it's the MCQ type of pattern or the theory pattern. So according to theory pattern, I'm saying this one. If it's the MCQ pattern, now you'll get at least 2 or 3 questions from the solid state. Okay, based upon the syllabus. Even for the competitive exam, also you'll get the at least minimum of 3 questions for the solid state. If it's a board exam, now you'll get the more number of questions only. And these are the subheadings for this topic. So properties of solid, types of solids, amorphous, crystalline, classification of solids, metallic solids, network solids, molecular solids. Can you hear me, Daria? Unmute yourself and you can say something. Can you hear me properly or not?
Yes, sir.
Okay. So these are the different types of solids: metallic solids, covalent solids, molecular solids, polar, non-polar, hydrogen bonded, and ionic solids. And after this, we are going to study about the space lattice and types of unit cells and the packing efficiency, electrical properties, imperfection in the solids. Okay, so in the last class, we covered just about the properties of the solids and the types of solids. This is what we covered in the last class. So today we'll study first the classification of solids. If you have any doubts in the last class, you can ask me so that I'll repeat you again. Any doubts? Ramcharan, Teja, and Vishwanath?
No, sir.
So what is the meaning of anisotropy? What is the meaning of anisotropy? What is the meaning of anisotropy? Any one of you? The physical properties will be different in the different direction inside the solid is called as an anisotropy. If we have the different physical properties, then what are the physical properties? Plasticity, elasticity, melting point, boiling point, refractive index. Like this. If these physical properties are different in the given solid in different directions, then it is called as an anisotropic in nature. Isotropic means iso means same. So all the physical properties will be similar in the different direction inside the solid. That is the meaning of isotropic in nature. Okay. So today we'll start with the classification of solids. So just you'll get one question at least from this. Okay. So metallic solids. So what is the first? If we discuss about the tabular column, the first column indicates about the type of solid. Second column tells about the concentrating units. Third column tells about the interparticle force. And the fourth column about the examples of the given solid. Fifth column about the physical state. And the last column about the electrical properties. So when we discuss about the metallic solids, only the metal atom will form the solid. So metal atoms are the constituent particles. And between the two metal atoms, there will be force of attraction that is called as a metallic bond. Okay. So metallic bond is nothing but the force of attraction between the kernel and the mobile electrons. Now tell me, what is the meaning of kernel? Any one of you? I have written the kernel, right? What is the meaning of kernel? Anybody? Kernel means suppose if you take the atom, any atom like we'll take a sodium as a metal. What is the electronic configuration of sodium? What is the electronic configuration? Total we have the 11 electrons, right? So first shell will take 2 electrons, next shell will take 8 electrons, and the last shell will have the 1 electron. Okay. So kernel is nothing but the combination or addition of inner electrons along with the nucleus. Okay, kernel means inner electrons of the atom along with the nucleus. That is called as a kernel. So whatever the force of attraction is there between the kernel and the mobile electrons. Mobile electrons means what? Whichever the electrons are present in the outermost shell of an atom. That is called as mobile electrons. Or the other name is valency electrons. Mobile electrons are valence electrons. So whatever the force of attraction is there between the kernel and the mobile electrons is called as a metallic bond. So examples are aluminum, gold, copper, ferrum. All these are the metallic solids. Generally, if you take the metals also in the periodic table, all are in the solid format only, except lithium, sorry, except mercury. Remaining all the metals are exist in the solid. Only the mercury will exist in the form of liquids. And what is the physical state? We know the metallic properties, right? They are the ductile in nature and the malleable in the nature. Ductile means what? Ability of the metal converting into the thin wire. That is called as in ductile. Malleability means, what is the meaning of malleability? What is the meaning of malleability? Anyone? What is the meaning of malleability? Area? Guys, give the answer whether it is a correct or wrong. No problem. Vishwanath, Ramcharan, the area in Vishwanath. Okay. So if you don't know, also you can tell me directly, or if you want to, you can keep the personal message to me. No problem. But give the answer either in the unmuting yourself or keeping a personal message to me. So malleability means converting the thick solid metal into the thin sheet. That is called as a malleability. Converting thick solid metal into the thin sheet. Suppose you are going for the bakery. You can see the aluminum foil, right? Actually, aluminum is a solid, which is available in the thick, like a thickness will be very large in the metallic format. But we are converting the thick solid into the very, very thin sheet by beating that. That is a malleability property. Like aluminum foil also you can make very, very thin sheet. That is a malleability. Ductility means what? Converting the metal into the thin wire. Suppose you're using the electrical wires. Electrical wires can be made up of copper or the aluminum. So copper is a metal converting into thin wire, that is a ductility. Clear now? These two terms.
Yes, sir.
Okay. So these are the malleable and the ductile, that is a physical state and exist only in the solid shape. And the electrical properties, generally all the metals are good conductor of electricity. Okay. So these are about the metallic solids. Next one is the ionic solids. Generally, we take the ionic compounds, they will have the both the ions, cations and the anions. Cation means what? Positive charged particles. Anion means what? Negative charged particles. So whatever the force of attraction is there between the cation and the anion, that is will form the ionic compounds and the ionic solid. What are the examples? Lithium chloride, zinc sulfate, magnesium chloride. Can you understand my handwriting?
Yes, sir.
Okay. So generally ionic solids are also solid in state only, but they are brittle in nature. What is the meaning of brittle nature? Suppose you have taken the sodium salt, like a sodium chloride salt. If you break with a hammer, what will happen? If you hit the sodium salt with the hammer, now what will you get? It will break into small pieces, right? They don't have any elastic properties. They will break into the very small pieces. That is a brittle nature. If you hit with the hard substance, now it will break into the small pieces. That is a brittle. So ionic compounds are generally solid in state, but they are brittle in nature. And ionic compounds will conduct electricity only in the liquid state or in the molten state. When they are in the molten state or in the liquid state only, they will conduct the electricity. When they are in the solid state, they will not conduct the electricity because in the solid state, the ions will not move, right? So they will not move. Because of that, they will not conduct the electricity. Clear or any doubts in this?
No.
Any doubts? The next one is the covalent molecules or the network solids. In this, the constant particles are the atoms, and the force of attraction between the atoms is the covalent bond. Generally, if you take the network solids, now it is a diamond and the graphite. So you know already diamond. Can any one of you tell me what are the properties of diamonds and graphite? What are the properties of diamond and graphite? Any one of you can tell me? Generally, if you take the diamond, it is a three-dimensional crystalline solid, and each carbon inside the diamond is bonded with the four other carbon atoms to form sp3 hybridization. So there is no free electrons at all in the diamond, right? So they will not conduct the electricity at all. So they will act as a insulators. One minute, please. They'll act as a insulators. And the same way with the graphite also. What is going to happen with the graphite? Graphite, in the case of graphite, each carbon is bonded with the three other carbon atoms. So the fourth electron will be free. So these fourth electrons will conduct the electricity. So with these fourth electron is there, there is a free electron, so it will conduct the electricity. So it will act as a conductor. And these are generally, if you take the diamond, it is a hard solid. It is the hardest substance known, and graphite is a soft one. So diamond will act as the insulator, and the graphite will act as a conductor. Okay. And the next one is the polar molecules. What is the meaning of polar bonds? If they have the dipole moment between the two atoms, those molecules are called as a polar molecule. If they don't have any dipole moment between the two molecules, those are called as a non-polar molecule. I hope you remembered in the class 11th what is a dipole moment and what is a non-dipole moment. Yes or no? Remembered or not? So in the case of polar molecules, the molecules will be the constant particles. They have the dipole moment between them. So there is a dipole-dipole interaction between the particles. So dipole means what? Due to the forming of partial charges on the atom, it will cause a dipole moment. So example of the polar molecule is a HCl. Generally, these polar molecules comes under the covalent compounds only. So covalent compounds means they have the weak intermolecular force of attraction so that they are not very hard. So they are called as soft solids. And covalent bond means what? Mutual sharing of valence electrons, right? So there is no ions at all. So they'll act as insulators. There is no free electrons. There is no free ions. So polar molecules, non-polar molecules, hydrogen bonded molecules, all will act as insulators only. Okay, next one is the non-polar molecule. So again, the same molecules are the constant particles, but here there is no dipole moment at all. That's why the van der Waals force of attraction will plays an important role. So van der Waals force of attraction is nothing but the force of attraction between the two different molecules is called as a van der Waals force of attraction. And there is no dipole moment or there is no ionic force of attraction at all in this case. So simple two same molecules are there. There is a van der Waals force of attraction. So I2, Br2, H2. Again, we can say how along with this, the covalent bonding will be happened between the I2, Br2 and the H2. Again, these are the soft solids and act as insulators. And the last one is the hydrogen bonded. What is the meaning of hydrogen bond? Anyone of you can tell me? What is the meaning of hydrogen bond? Unmute yourself and you can tell. It's okay if you're telling the wrong answer, no problem. I will not tell you anything or I will not scold you, okay? Don't have that fear at all first. Unmute yourself and you can tell the answer. What is the meaning of hydrogen bonding? Dhairya, Ramcharan, Vishwanath,
So the interaction of hydrogen bond.
the interaction of
So the interaction of between the hydrogen atoms.
okay, the interaction between the hydrogen atoms and
Located between the here.
no. What about the other two, Dhairya and the Vishwanath? Hydrogen bonded means the bond between the hydrogen and with three other most electronegative elements. The bond between the hydrogen and the three other most electronegative elements. Now, can you tell me what are the most electronegative elements in the periodic table? Which one is the most electronegative element in periodic table?
Fluorine.
Very good. Fluorine. Next, oxygen, and the last one is the nitrogen. So these are the three most electronegative elements in the periodic table. So whenever the hydrogen is bonding with these three elements like fluorine, oxygen and the nitrogen, it is called as an hydrogen bonding. Okay. Fluorine, oxygen, and the nitrogen. So whatever the bond is forming between the hydrogen and fluorine, or the hydrogen and oxygen, or the hydrogen and nitrogen, it is only called as a hydrogen bond. Okay. So hydrogen bonding, again, the hydrogen bond only will be there between the particles. Example, if you take water, it will have the hydrogen bonding. Alcohol, it will have the hydrogen bonding. NH3, it will have the hydrogen bonding. Okay. But what about the HCl? Is it having hydrogen bonding? If you take HCl, is it the hydrogen bond? So this is the first one, this is the second one, this is the third one. Now tell me which one is having the hydrogen bonding and which one is having the covalent bond or the ionic bond. Fast. No problem if we give the wrong answer also. So if you take the first one, HCl, there is no hydrogen bond at all, because hydrogen bond means what? Bond between the hydrogen and fluorine, or hydrogen and oxygen, or the hydrogen and nitrogen. That is only the hydrogen bond. If you take the HCl, there is no hydrogen bond at all. It is a normal covalent bond. If you take the H2O, okay, hydrogen and oxygen is there, so it is a hydrogen bond. And if you take H2S, again there is no hydrogen bond at all, because the bonding between the hydrogen and sulfur is not the hydrogen bond, it is a covalent bond. Understanding? So only in the second case, that is a H2 only, we have the hydrogen bonding. So again, these are the soft solids and will act as a insulators. What is the meaning of insulators? What is the meaning of insulators? Guys,
So the electric current does not flow freely.
electric current does not flow freely. Very good. They will not conduct the electricity alone. That is the insulators. So any doubts in this tabular column, you can ask me. I will explain it. Any doubts?
So your voice is coming low, sir.
Voice is coming low. Now is it fine?
Yes.
Okay. So please, if you're facing any issues now, like a voice is breaking or voice is coming low, or you can't understand sometimes, you can ask me immediately. Okay, then only I can rectify that one, right?
Yes.
Yeah, thank you for telling this. Yeah, you have any doubt in this tabular column? Because if I take as a theory partner, it will take completely 2 or 3 pages. But if you take this as a tabular column, it will be easy to study for you. And you can remember easily. Any doubts?
No, sir.
Okay, what they are telling here, any doubts in this kernel part? Suppose if you take the aluminum, what is the meaning of kernel? The force of, what is the meaning of metallic bond? The force of attraction between the kernel and the mobile electrons is called as a metallic bond. So kernel means what? The innermost electrons and the nucleus combinedly called as a kernel. Clear? So that is what I explained with the example. If you take aluminum, it has electronic configuration of 1s2, 2s2, 2p6, 3s1. 3s1 is the valency electrons or the mobile electrons. The below configuration, that is a 1s2, 2s2, 2p6 is the innermost electrons. So this innermost electrons and the nucleus is called as a kernel. Clear? Is it clear or not? Understood or not?
Yes, sir.
Okay. So this one we'll do it afterwards. So next we'll come back to the topic space lattice or the crystal lattice. So now onwards it is a completely three-dimensional topic. Okay. So please try to understand. If you have any doubt, you can ask me at that point itself. Okay. The first one is the definition for the crystal lattice or the space lattice. What is the definition? It is defined as a regular three-dimensional arrangement of identical points in space. The position which are occupied by the atoms, ions, or the molecules in the crystal lattice are called as a lattice point or the lattice sites. So if you take some particles, if you are arranging that particles in some space in three-dimensional way, that is called as a space lattice or the crystal lattice. Clear? Suppose you have taken 8 points and arranging in the form of cube in three-dimensional way, it will form the space lattice. And if you have taken the 12 points or the atoms or the ions and arranging in the hexagonal form in the three-dimensional way, it will form the crystal lattice or the space lattice. Clear now? So we
Yes.
are taking some atoms and we are arranging that atoms in the space in three-dimensional way, not in the one dimension or the two dimension. If you are arranging those atoms or the ions or the molecules in some space, that space is only called as a space lattice. And wherever we are placing the atoms in that space, that is called as a lattice point. So if you take below as an example, one cube we have taken. In that cube, we are not placing anywhere, just we are placing the atoms at the corner of the cube. So total 8 corners are there in the given cube. So we are placing all the 8 atoms at the 8 corners. Now that cube is the space lattice, that corner is the lattice point. Fine. Any doubts in the definition? Am I going very slow or very fast? Or is it okay?
Okay, sir.
Okay. What about the area and Vishwanath? The area in Vishwanath.
Yes, sir.
Understanding? Or am I taking very fast? Give your replies, no problem.
No, sir.
Can I know for what no it is? The area? Okay, sorry, there is no more image now. Wait a minute, please. So what is the meaning of unit cell? Suppose if you take the matter, atom is the smallest particle of the matter, right? So if you study about the one atom properties, then it is resemble to the complete matter properties. Okay, we don't want to study the complete matter properties. Just you study only one property of the atoms. That is enough. Like that. If you want to study about the complete solid, okay, we don't want to study all the properties of the solids, especially individually and all. Just you take one unit cell of that solid and study the properties of that solid, because unit cell is defined as the smallest block of the crystal lattice from which entire crystal can be built up by its repetition in the 3 dimension. So this is the smallest block of the crystal lattice. If it repeat the same unit cell in the 3-dimensional way, again it will form the space lattice only. That is what the meaning. So if we study the properties of the unit cell, it is similar to the properties of the particular space lattice. Okay. So generally we'll draw the unit cell in this cubical format. So when you take the unit cell, totally it has the 6 parameters. Like 3 parameters of the edges, like length, breadth, and height. Like A is the, you can take as the length, B is the breadth, and C is the height. And 3 angles will be there between these A, B, C. Alpha is the angle between the B and C. Can you see the image properly? Or can you zoom it?
Okay, sir.
So alpha is the angle between the B and C. Then what is the beta angle? Beta is opposite of B, right? So it is the angle between the A and C. And the gamma is the angle between the A and B. So A, B, C and alpha, beta, gamma are the 6 different parameters for the particular unit cell. So based upon these 6 parameters only, we have the different types of crystal systems. Or we can say total 14 Bravais lattices will be formed. Okay, I will show you the diagram also one by one. Okay, so if you take a particular unit cell, we have the different terminology for the unit cells for each and every part. So first we'll start with the corners. You know about the corner, right? If you take a particular cube, you know about the corner. Wherever the joining of these 3 lines is called as a corner, and the edge. What is the edge here? The length or the breadth or the edges. So this is the edge length. Okay, and if you take the cube, how many faces will be there in the cube?
6.
Will be there. You know what is the face also. Okay. The next one is the edge center. Edge is different. Edge center is different. If you are placing the atom at the center of the edge, that is the edge center. If you are placing the atom at the center of the face, that is the face center. Okay. The next one, body diagonal and the face diagonal. Face diagonal means what? The line connecting between the 2 opposite end of a face. That is a face diagonal. Can you see clearly in the picture here? If you take one particular face, the line joining the 2 opposite corners, that is called as a face diagonal. But what is a body diagonal? What is a body diagonal? If the line joining from one corner of the face to the other corner of different face, that is called as a body diagonal. Okay, now you tell me which one will have the more length, face diagonal or the body diagonal?
Body diagonal.
Can you tell me the value? If you take it as a cube with having edge length A, what is the length of the face diagonal? Anyone? What is the length of the face diagonal? Whether you know or don't know, or any guess? Face diagonal length is root 2a. If you have the edge length is a, then face diagonal length will be root 2a. Then what is the body diagonal length? It will be root 3a. What is the body diagonal length? Root
Root 3.
You remember that one, okay? we'll use in the next part of the chapter. So any doubts in this diagram? Edge, corner, face, face center, edge center, body diagonal, body center. Because these are the lattice points inside the unit cell. Generally, we'll place the atoms or the particles at these points only, the corner or the edges or the edge center, face center, body centered, along the face diagonal or along the body diagonal and all. Okay. So if you take the particular unit cell, how many edges will be there in that? If you take a particular unit cell, total we have the 12 edges. And how many number of faces? 6 faces. And total number of corners? 8. And number of body centers? We have only one body center, right? Along the body diagonal, that is a 1. But number of edge centers? Total we have the 12 edges, and along with each edge, we have the edge center. That is the total number of edge center is 12. And face centers, total we have the 6 faces. So face centered also 6. How many face diagonals are there? Total we have the 6 faces, and each face can form 2 diagonals. So 6 into 2, total 12 face diagonals. And total body diagonals are 4. So you can form totally 4 different body diagonals. Any doubts in this?
No, sir.
How to remember these values? Because next we'll calculate the number of effective number of atoms, Z value. In that it will be very useful. If you have any doubts, you can ask me, I'll explain you. Any doubts?
No.
Okay. So next one is the just now we discussed about the unit cell simple. Now types of unit cells. So what is the types of unit cells? So first one is the simple unit cell or the primitive unit cell. Simple unit cell means what? If you take particular unit cell, the atoms will be there only at the corners. If the atoms are there only at the corners, it is called a simple unit cell or the SCC. Okay, simple unit cell. But if the atoms are there along with the corners and at other places like a face centered or the body centered, it is called as a centered unit cell. So simple means what? Atoms will be there only at the corners. The next one is a non-primitive or the centered unit cell. In this, we have the 3 different types: face centered, body centered, and the end centered. So when you take the face centered, the particles present at the corners as well as at the center of each face. So if you take the atoms will be there along the corners. There is a common, and along the corners also we have the each atom at the face centers. Clear? Now tell me, how many total number of particles are there in the given unit cell? How many total number of particles are there? 8 at the corners, 6 at the faces. Total 14.
14.
Okay. But all these 14 will not belongs to only one unit cell because it is commonly sharing with others also, right? So that we'll discuss afterwards. But normally if you take the face centered, now 14 will be there. Okay. The next one is a body centered. Body centered means what? Atoms will be there along all the corners. 8 atoms at the 8 corners. Along with that, one atom will be there at the center of the body. So this is a body centered. Can you understand the diagram part?
Yes, sir.
This is a body centered. Now I have a small doubt. Okay, so body centered means what? 8 atoms are there at the corners and one atom will be there at the center of the body. That is a body centered. The last one is the end centered. What is the end centered meaning? What is the meaning of end centered? N-centered means 8 atoms will be there at the 8 corners, and the 2 atoms will be there at the center of each face, or we can say opposite faces. So 8 atoms at the corner, that is a common one, and the 2 atoms are there, right? They are present at the 2 opposite faces, either in this direction or this direction or in the this direction. So compulsory 2 atoms will be there at the 2 opposite faces, that is the N-centered. So any doubts in this types of unit cell?
Clear, sir.
So we have the simple unit cell, which will have the atoms only at the corner. Next one is a centered unit cell. First one is a FCC. FCC means what? 8 atoms at the corner and 6 atoms at the center of each face. The next one is a BCC. 8 atoms at the corner and 1 atom at the center of the given unit cell. And the last one is a N-centered. That means 8 atoms at the corner and 2 atoms at the center of the opposite faces. Fine. So this is what. So based upon that, you can have the different types of Bravais lattices based upon the unit cell parameters. Now can you see it properly? So total we have the 7 crystal systems are there based upon the 6 different parameters, and it will form the 14 Bravais lattices. So the first one is if all the sides are different, the length of all the sides are different and all the angles are different, it will form the triclinic. The center one is called as a triclinic. Okay. And if you take the starting one, it is a cubic system which will have all the sides same. If you take a particular cube, all the sides will be same, right? Length, breadth, and height. So ABC, A equal to B equal to C, and all the angles will be same. That is exactly equal to 90 degrees in the case of cubic system. So alpha equal to beta equal to gamma equal to 90 and A equal to B equal to C. That is in the case of cubic. Next, tetragonal. So in the case of tetragonal, what is going to happen? Here A equal to B. That means two sides will be similar, but which is different from the third side. So A equal to B not equal to C. But all the angles are same. Alpha equal to beta equal to gamma equal to 90 degrees. So it will form the tetragonal. So again, the tetragonal, we have the 2 types of unit cells, simple and the BCC. And the below one is a orthorhombic. So in the case of orthorhombic, A not equal to B not equal to C. That means all the sides are different in length and all the angles are same. Alpha equal to beta equal to gamma equal to 90. So all the angles are same, but all the sides are different. Okay, so that is about the orthorhombic. The next one is if you take the right side part, rhombohedral, in which case A equal to B equal to C, but angles are different. Alpha equal to gamma equal to 90 degrees and beta not equal to 90 degrees. That is a rhombohedral. And the next one is a hexagonal, A equal to B not equal to C, but alpha equal to beta equal to 90, but gamma equal to 120 degrees. And the last one is a monoclinic. In this, A not equal to B not equal to C, but alpha equal to gamma equal to 90 and beta not equal to 90. Maybe it is a confusion for you if I tell like this. In the next class, I'll explain you clearly each and every system. And if you remember this chart, it will be easy for you to remember all the 14 Bravais lattices and the 7 crystal systems. Okay. Is it clear? Just go through this chart In the next class, I will explain you clearly once again all the things. But any doubts in today's class?